Okay, this is problem number 1A. So we have this car. It looks like it's kind of going down a hill. It tells us velocity is pointing downward and to the left, and your acceleration for that car is the exact same direction. Okay, that's the key for all of these problems on the front page. If your velocity and your acceleration are the exact same direction, the object is going to speed up. In fact, that's something I'd probably write down anywhere you have room for notes on this page. I'll go ahead and type that up here. If your velocity and acceleration, I have to make this smaller in a second, are same direction. See if I know what I'm doing here. Then the object speeds up. So write that down somewhere on this page. The opposite of that you can probably guess. If velocity and acceleration are opposite direction, the object slows down. So somewhere on your page, if you have room, you can abbreviate, you can pause the video and write it all out, but write that down. If it's in the same direction, it speeds up. If they're in opposite directions, it slows down. Okay, so for this problem, we have to give a description of the motion of this car. We have velocity going down to the left, acceleration also that direction. So tell me the direction of each. So the first thing you'll have to do is tell me what is the direction of your velocity and your acceleration. Velocity in this problem is going down and left, so let's call that the negative direction. You can just put a minus sign if you'd like. Our acceleration is in the same direction, so it is also negative. Last thing you have to do for your description is simply tell me, does this object, in this case the car, speed up or slow down? Because our velocity is negative, our acceleration is negative, they're going in the same direction, we know the car is going to speed up. Add some emphasis to that, maybe. Or not. Okay, the last part is your motion diagram. So the first step to a motion diagram, we need to make that axis. Get my tool here, we're going to have an arrow across the bottom. It's moving to the left, so I'm going to have my arrow face to the left. We have a line over here showing where it starts, in blue I suppose. We label that 0. And it's moving more left and right, I guess, so we can use X to label that as our position. Okay, over time, this starts on the right side and moves to the left, and we know it speeds up as it goes. So your first dot should be pretty close, and over time, these dots are getting further and further apart. 3 will be enough, 3 arrows. So we connect those positions with velocity arrows. So these little arrows connect our dots, showing us the direction of motion and that speed is increasing. Because there's acceleration, we also need to include acceleration arrows. So above each dot, we should also have a little arrow pointing in the same direction. If you have troubles with acceleration arrows, remember those little arrows always point to the larger of the 2 arrows below it. So that's it for problem 1A. Let's try to do the same thing on B now.